There are several properties from algebra that we will be talking about, but first I need to apologize for not having the webcam. For some reason it's not working, so you will just be looking at my screen and not at my face. Anyways, we have several properties of equality here, and then we will have a couple of properties of congruence. So without further ado, let's start with properties of equality. And the first one is called an addition property. It is very simple. It says that if A equals B and C equals D, so we have four numbers, A equals B and C equals D, then we can simply add them. So A plus C is going to be equal B plus D. So we add the left sides and then we add the right sides, and we still have the equation, the equality. For subtraction property, it is a variation of addition because we know that subtraction is basically adding a negative, so we don't even need to say subtraction property. We could have included it in addition property, but since we have it here, let's state it. C equals D, so starts the same way. The only difference is that A minus C is going to be B minus D, like so. But again, as I said, addition and subtraction property, that is basically the same thing, and we don't even actually need the subtraction property. Similarly, for multiplication property, we are going to start with if A equals B, then there is no C equals D, then C times A is going to be equal C times B. If I multiply both sides of equality by the same number, it's going to stay the same. For division property, very similarly, I start with if A equals B, then actually I cannot put then because I'm going to be dividing, so I will have to say that I will have to specify that C does not equal 0 because I don't want to divide by 0. So then A over C is going to be equal B over C. And just like with addition and subtraction, those are very similar properties. You can say that division is multiplication property, you're multiplying by 1 over C, but there is a big difference here because in this case, you have to specify that C does not equal 0. In subtraction, we didn't have to make any other requirements. We just subtracted, but for division, we have to make sure that the denominator does not equal 0. All right, moving on to substitution property. In substitution property, we would say that if A equals B, so starts the same way. If A equals B, then we can substitute either A or B in the other equation for each other equation or inequality. So we would say then either A or B may be substituted, for the other in any equation or inequality. In any equation or inequality. That works as well. Very familiar example is when you are solving a system of linear equations, not with A and B necessarily, but maybe with X and Y. So you have something like X plus Y equals 3, and then you have 2X minus 5Y equals 8. So then when you're working it out by substitution, you can say from the first equation, X equals 3 minus Y, and then you take this and then you substitute instead of X. So then your second equation is going to look like 2 times 3 minus Y minus 5Y equals 8, and then you solve for the Y. Or alternatively, you could have said y equals 3 minus x, and then you substitute instead of y, and then your equation becomes 2x minus 5 times 3 minus x equals 8, and then you solve for x from this equation. So that is what our substitution property is telling us. You can substitute either one for another in any equation or inequality. Reflexive property. If you look at the left side, we're actually going to have these three properties: reflexive, symmetric, and transitive property for congruence as well. So those are very important to remember. Reflexive property is very simple. It's when you look at yourself in the mirror, you see a reflection. Just think about that. Reflection of you is you. So A equals A. Wow. An epiphany. I know. Reflexive property. Okay, that's it. Symmetric property, also very simple. If A equals B, then guess what? Surprise, surprise, B equals A. Right? So all those are very logical, make sense, don't need to explain much about them. And transitive property is another one that we use often. If A equals B and B equals C, equal sign, then we can say that A equals C, right? Also makes sense. If I say 2 plus 3 equals 5, and I know that 5 equals 4 plus 1, so this one is a little tricky. So my A is going to be 2 plus 3, and then C is 4 plus 1, kind of, right? And then B is 5, it's the same. So then I can say that 2 plus 3 is the same as 4 plus 1. So in this case, A is not just a single number, it's a sum of numbers, but nobody said here that it has to be a number. It can be any expression. Now, if we translate this transitive property or tie it with congruence statements, then this is how they are going to look like for congruence statements. So for reflexive property, I would say that I have, like, for example, I have a figure, a segment, and I'm going to call it segment DE. Right? So if I have a segment DE, it is going to be congruent, not equal anymore, to a segment DE, to itself. And then the second thing that I can say, if I have, for example, an angle D, then it's going to be congruent to angle D, to itself. Right? So if I have a segment DE here, it's congruent to itself. And then if I have angle D, should have called a different name, then same thing, it's congruent to itself. So that is your reflexive property. We will use it when we will have later on maybe some overlapping triangles or triangles that maybe share the same side. So if you see something like this maybe, so you have a triangle and then you share, and the triangles share this side, then maybe we will try to prove that one triangle, maybe triangle over here, is going to be congruent to maybe triangle over there at the bottom. And then one of the steps is going to be to say that, well, this side is congruent to itself because of reflexive property, which right now might look a little silly, but then in the future you will know that if you have this in your bag of tricks, it's going to be much more helpful for you to work with congruence proofs. Symmetric property, if DE is congruent to FG, to another segment, then we can say that segment FG is congruent to segment DE, right? Makes sense. So this is my segment DE. I am going to draw a segment FG over here. Oh, I tried to change the color and it didn't work. So if DE is congruent to FG, then FG is congruent to DE. Okay, makes sense. And if I'm looking at the angles, so similarly, I would say if angle D is congruent to angle E, then angle E is congruent to angle D. So same thing, I have angle D over here. If I have angle E, let's put it this way, angle E, right? D is congruent to E, so E has to be congruent to angle D. My final property is transitive property. So now here I will have to deal with 3 segments or 3 angles. So I'll try to fit them all in here. So I would say if segment DE is congruent to segment FG and segment FG is congruent to segment JK, then I can say that segment DE, the very first one, is congruent to segment JK. And I don't have space here for the diagram, so I'm going to put it on the side. So this is my segment DE. I have another segment FG, and I know that these two segments are congruent. And then maybe I have another segment, JK, over here. And somebody told me that JK is congruent to FG. Well, that means that JK has to be congruent to segment DE as well. Okay, should make sense. Same thing for the angles. I would say that if angle D is congruent to angle E, and angle E is congruent to angle F, then angle D is going to be congruent to angle F. Right? So same thing, if I have my angle D over here is congruent to angle E over here, and that angle is congruent to angle F over here, then angle D is going to be congruent to angle F, right? Because they're both congruent to my angle E. And I'm going to show you, I wanted to show you a little example on how we can use these properties in our properties of algebra for, let's say, solving an equation 3x equals 6 minus, let's throw a fraction in there, 6 minus 1/2 x. Yes, so our first step is going to be to say that 3x equals 6 minus 1/2 x. And the justification for that is going to be, well, that's the equation that is given to us. So then for the second step, probably we will multiply, one of the things that we can do is we can multiply both sides by 2 so that we can get rid of the fraction. So we can write down 6x equals 12 minus x. Why? Because of multiplication property. We multiplied multiplication property of equality. Right? We multiply both sides by 2. Then it looks like we might want to have x's on the left side. So we are going to add this x to both sides. And then now we have 7x equals 12. So what did we do? We added x. If we added x, then it is, addition property. Addition property of equality. I'm abbreviating here, equality. And then step number 4, I can say that x equals 12 over 7. Why is that? Because I use division property. Division property of equality. I divided both sides by 7. And on the left side, what we did on the left side, we wrote down our steps. And then on the right sides, we gave the reasons why. Reasons why. So that is going to be my last example here. So that is it. Thank you very much.